Hey Techno Studs, in this video we're going to talk about spanning tree protocol versions. Throughout time, we have developed spanning tree protocol and made improvements on it. And Cisco has also made additional improvements, and so there's some proprietary protocols that just Cisco has. So let's talk about some of the different versions that you would find out there. In this video, we're just going to give a brief overview of the top versions that you would see, and then we're going to get into specifically about spanning tree protocol versus rapid spanning tree protocol and see some of the differences between those and how it designates alternate and backup ports. So we'll get in more in depth into that. The original spanning tree algorithm actually dates back to 1985, so it's been around for a while. One of the original spanning tree protocols that was defined was 802.1d was in 1990, although it's been developed more since then. So it wasn't something that was stagnant and then stayed that way. It actually developed a little bit more throughout time. But that's the original spanning tree protocol. Then we get into a per-VLAN spanning tree protocol, or PVST, or later on it became PVST plus. So this is a Cisco proprietary, so Cisco developed it. It was based off of that original spanning tree protocol, the 802.1d, but it had some additional functionalities. And one of the ones it really had was a per-VLAN. You were able to allow different VLANs to have different ways that they would direct traffic. This allowed you to do maybe some sort of load balancing where you would send some traffic from some VLANs one direction and then another VLAN traffic another direction. Then we got into rapid spanning tree protocol. Some of the problems with the original spanning tree protocol was it was very slow to converge, or very slow to actually bring the ports live. So rapid spanning tree protocol was developed to significantly increase the speed that access ports would come back up and increase the recovery time of the different ports as well. And so that was defined by 802.1w. Then Cisco decided, hey, we want to create our own version of this, so they created rapid PVST plus. They took their PVST plus and then they incorporated some of those things that 802.1w had into it and created rapid PVST plus. And then a more recent one was the multiple spanning tree protocol. So this is IEEE's answer to having multiple VLANs, and that was 802.1s. And then Cisco came out with their MST, which is Cisco proprietary, based off of that same one. So there's a history of both IEEE and Cisco kind of using each other's ideas to come up with some of these protocols, but Cisco would always take whatever IEEE would come up with and then develop a standard that had some improvements on it, but didn't work with all of the devices, only worked with Cisco devices. It was Cisco proprietary. So those are some of the different versions that you may see out there. One of the improvements that rapid spanning tree protocol did was to lessen the time that a port remained in that area where it wasn't really doing much. So it combined the disabled, blocking, and listening all into one discarding. So it's very much simplified that into discarding, where it still received bridge protocol data units. It still received those. It just didn't throw those away, but it wasn't necessarily forwarding traffic in that time. So this drastically reduced the time that spanning tree protocol has to bring up a port live. And then it still has the learning and the forwarding states. So what it does is it just takes the states and reduces the amount of states that these different ports are in. It allows that max age and forward delay, so that 25 seconds, you can recover up to 25 seconds with that by cutting some of that out. The other thing it did is it gave a little more granularity to a non-designated port. So with spanning tree protocol, we have this blocked port or non-designated port, or we also had called it alternate port. Well, rapid spanning tree has what's called a backup port and an alternate port. And what this allows is it allows us spanning tree protocol to understand what's on the other side of it. Is it a switch on the other side, or is it some other server or some other device or resource on the other side? Because if it is an alternate port and then there's a switch on the other side, then I can switch over to that alternate port much quicker. So the idea is in the event of a failure, then I can turn on that alternate port much quicker and have my network heal much faster. So maybe you have something like a server that's sitting off here to the side and it has multiple links into your switch. That would be considered a backup port with this, versus an alternate port would be a secondary route to that root bridge. And so this is an alternate route for other devices to go. So if something were to happen to the original path to that root bridge, then it would take that alternate path. So that's the difference between an alternate and a backup port. So adding that designator of alternate versus backup port allows this network to heal much quicker. Okay, that was a pretty quick video of just some of the STP versions, some of the differences between STP and RSTP, and we finished it up by talking about that alternate and backup ports for the quicker healing, so that way the network can heal much faster.